Hello, ladies and gentlemen. Welcome once again. What I want to do today is simply go over some of the problems that were assigned, enough to give you an example of how to do these in case you're attempting these on your own, as you should if you didn't finish in class or if you were not present. So let's go back to the first few. We're in activity 15 practice. Let me just reload the screen. And so today we are going to be doing numbers. There we go. We are going to be doing numbers 1 through 6. Give me 1 second as I undo what we did in class. So again, we're going to be doing numbers 1 through 6. 1, 2, 3, 4, 5, 6, as well as numbers 20, 21, 22, 24, and 25, not 23. So 20, 21, 22. Actually, we're not doing 22 either. I did just take that one out. So 20, 21, 24, and 25. 24 and 25. Numbers 1 through 4, all we're doing is we're writing an inequality. All right, we're going to take this statement and translate that into an inequality. So reading number 1, it says a number is at least 6. So a certain number is being compared to the number 6. So let's circle the important information. So we have a number is at least 6. In my experience, ladies and gentlemen, the easiest way to do these is to begin with a variable, a certain number. We don't know what that number is. And then the number that we're comparing it to, that being the number 6. All right, so that number needs to be at least 6. So again, in my experience, what I do is that I begin with a symbol and ask myself, does this make sense? For example, if a number has to be at least 6, can that number be less than 6? Okay, so if I needed at least 6, let's say you need at least 6 points to win. Could you win with less than 6 points? No, that obviously doesn't work. Well, then let's try the opposite. Could you win with more than 6 points if you need at least 6? Yes, that works. Could you win with exactly 6 points? Again, yes. So not only could you win with more, but at least 6 implies that you could also do it with exactly 6. So this right symbol is that x needs to be greater than or equal to 6. Greater than or equal to 6. And that would be my answer to number 1. You would select this symbol. Let's try number 2. Let's do it over here. 7 is less than a number. So we're comparing a number to the number 7. And 7 is less than that number. So obviously that number needs to be greater than 7. It cannot be equal to 7. Nope, it has to be greater than 7. That is the answer to number 2. Let's try one more. Number 3, no more than 100 people fit on the plane. So we're going to start with a variable. We always begin with a variable. That's going to be the people that fit in the plane. And we're comparing that to 150. And it says no more than. So could we have more than 150? By definition, no, we cannot. So let's try having less than 150. Can you fit less than 150 people on that plane? Yes, you can. Could you fit exactly 150 people on that plane? Yes, that makes sense as well. And so that would be my inequality. So as you can see, ladies and gentlemen, and you would do the same thing for number 4. Again, you begin with a variable. You begin with a variable and the number that you're comparing it to. Number 4, the maximum score. Okay, that is the maximum score, or our score on the pilot's test is 95 points. So we're comparing the score to 95. And if 95 is the max, can you go more than 95? No, your score has to be less than 95, or it could be exactly 95. And there is my inequality. Pretty simple. Look at number 5, though. Number 5 is simply asking, is 4/5 a solution to this inequality? X is less than or equal to 2. In other words, it's saying if we use 4/5 instead of x, is this a true statement? So is 4/5, I'm using 4/5 instead of x, I'm substituting it instead of x, is that less than or equal to, one of the two, to the number 2? Well, let's try it out. There's a couple ways of doing this. I think the most obvious way is that we can make the 2 into a fraction and just compare the fractions using the butterfly method. 5 times 2 is 10. 1 times 4 is 4. We can see that 10 is indeed greater than 4. So yes, 2 is greater than or equal to. In this case, it's greater than 5/4. So yes, this is a solution, and this is a true statement. 4/5 is a solution to this inequality. So anytime they're asking for a solution to an inequality, you just substitute it for the variable, whatever number they're wondering about, and ask yourself, is this a true statement? We do the same thing in number 20, if you don't mind me going from number 5 all the way to number 20. Look at what number 20 is asking. It's asking, is 10 and 3/10 is 10.3 a solution to the inequality x minus 2.5 is greater than 8. In other words, instead of an x, I'm going to use 10.3. And I want to see if 10.3 minus 2.5 really is greater than 8. We'll work that out. What is 10.3 minus 2.5? Is it greater than 8? If it is, then yes, it is a solution. If it is not, then the answer would be no. You can try that out on your own. Okay, again, just work this out. What is 10.3 minus 2.5? Whatever answer you get, ask yourself, is that greater than 8? If it is, then the answer is yes. 10.3 is a solution. If it's not, then the answer is no. No, it is not. Okay, let's go ahead and do number 6, and we'll do that one over here. It says, which of the following is a solution to x is greater than 10.4? In other words, ladies and gentlemen, I'm going to look at each of these 4 numbers, 5.2, 7.4, 9.6, and 11.2, and I'm going to ask myself, which of those numbers would make this a true inequality? For example, A, is 5.2 greater than 10.4? No, it is not. So A cannot be the right answer. What about B? Is 7.4, I believe. Is 7.4 greater than 10.4? Or 7.1, whatever it says right there. But no, it obviously is not. 7 is less than 10, so no, B cannot be the answer. So that is also what you're going to be doing for number 21. Which of the following is a solution for this inequality? In other words, instead of x, you're going to put 5.7 and see if this left side is greater than or equal to 10.2. Instead of x, you're going to use a 4 and ask yourself, is 4 plus 3.2 greater than or equal to 10.2? You're going to use each of these, and only one of these will give you a true statement that the left side is greater than or equal to 10.2. Finally, on number 24 and 25, ladies and gentlemen, all you have to do is isolate the variable. Remember, when we're solving inequalities, all you have to do is isolate the variable, see what do you have to do to make the variable be by itself. For example, in number 24, we have x minus 9.25 is less than 3.5. Okay, so I need to isolate the x. What's the opposite of subtracting 9.25? Well, of course, it's to add 9.25. Whatever I do to one side, I must do to the other. So I must add 9.25 on the other side. And x will be less than whatever 3.5 plus 9.25 is, and that's going to be your answer on Schoology. All right, ladies and gentlemen, I hope you found this video helpful. Just going through a few problems, just practice these inequalities that we've been doing. If you still have questions, we can address those during our next class. We'll see you soon.